going to be getting into some of the more complicated formulas tonight. So first off, and we have some sort of different topics here. First off, what we're going to look at is what they talk about the average daily balance. And they use this to compute, say, if you miss a payment or something like that, if you're late on a payment. So this is going to be on page 647. So how do they actually calculate this? What is this? Well, what it is, so let's say you do this, you miss a payment. So you're going to have a late fee. So we're talking about credit cards. You miss a credit card payment. Now, credit cards are important. You might have heard of something called the credit score. And credit scores are interesting. From my experience with working with them, you typically have a high credit score if you have a number of what they call open accounts. And this is often like a checking account, savings account. I'm not sure about savings. Savings, you got to be careful. But definitely like a credit card. They consider a credit card an open account. And the idea is you want to show that you are trustworthy with credit. Now, you might say, well, there's an easy way to get around this. Just never put anything on credit, have no credit cards at all. And if you do that, it's not going to give you a good credit score. They want to see you actually possessing accounts that, things you can owe on, and, making your payments, still keeping your debt relatively low, though. But once you have no accounts, it can really hurt your credit score. So I just want to let you know. So with credit cards, let's say you do have something you place on your credit card and you missed a payment. And just another thing to mention about credit cards, a good reason to have one, it's a good emergency account if something goes wrong. You could, if you have a $10,000 credit card or something like that, and suddenly you got hit with a catastrophic car accident or something like that, a tree falls on your car, say, and you've got to get a new car or some replacement. Credit cards are really good for those kinds of things. You really got to take care of something really quickly and it involves money. So not always a bad thing. But let's say you do have some debt on your credit card, and you got to make regular payments, and you want to make those. You definitely do. Missing payments can also hurt your credit score, so you want to make those regular payments. And oops, you missed one. No, it doesn't always hurt your credit score, but it can. And in that case, you usually get hit with a fee. So you're going to pay this late fee. So how do they come up with the late fee? And you might say, well, there's probably some standard fee, and that could be the case. But the one we're going to look at here is we're going to use something called an average daily balance to calculate the late fee. So what is this? Well, call it the ADV. So you're going to take the sum of the total amount owed each day. And we're going to talk a little bit about what this means. This might still be a little cryptic. Then we're going to divide by the number of days in the billing cycle. So take a look at this. Now, usually billing cycles are 30 days. So what we're going to be talking about in this section is usually month by month by month. So that means usually this is going to be 30, and this is going to be money you owe each day for 30 days. Now I'm going to do a very simple example, just 3 days. So with 3 days, let's say we have this. So we have a 3-day billing cycle. Now, the first day is when you buy something on your credit card. Let's say you buy something for $50. And then the next day, day 2, you don't buy anything. So how much do you owe on day 2? Well, still $50. You haven't paid any money back, you haven't made any payments or anything, and you haven't bought anything with this credit card, so it's still $50 on day 2. But on day 3, couldn't help it. There's those classic sneakers they had on eBay, and you're just like, I gotta get some of those. So you bought the classic sneakers, and those were $100. So at the end of day 3, you owe 150. So this 50 is here, but this is going to be eBay. An eBay purchase. So when we talk about the average daily balance, what we're going to do is day 1, we owe 50. Day 2, well, we still owe 50. We haven't bought anything, but we haven't paid anything off. Day 3, though, we bought something off of eBay. So we have $50 we haven't paid off, plus the $100, so that's $150 for day 3. So if we add up what we owed on each day, that's going to be that sum. In the numerator, or the top of this calculation. And then how many days are in the billing cycle? Well, in this one is 3 days.
Sir?
Yes.
This is 11.3 we're doing, right?
11.3, correct. I'm letting everybody know, again, if you're just joining us, I am recording the class. So if you haven't voted yet, you can go out and vote. I believe the polls, okay, now I'm in Eddy County. Eddy County, the polls are 7 o'clock. So double check with what's happening in Chavez County. If you haven't voted yet, get out there and do it. And this will be recorded for you to see. But just FYI. All right. So let me see, calculator. So if we add these up, we'll get 250 divided by 3. And so the average daily balance is about $83.33. So that's how we would calculate the average daily balance for 3 days. And if you're just joining us, what this is, if you bought something on day 1, say for $50, you didn't buy anything on day 2, but you didn't pay anything off either, you still owe $50 on day 2. So at the end of day 1, you owe 50. At the end of day 2, you owe 50. Day 3, you still owe the same 50, but you bought something on eBay. And so at the end of day 3, you owe 150. So the average daily balance is we take the balance at the end of each day and we average it over this billing cycle, the number of days in the billing cycle. So we add up all the balances, day 1, day 2, day 3, divide by the number of days, and that gives you the average daily balance. Now again, why do we want this? Well, if we miss a payment, we're going to use the average daily balance to compute the late fee. So let me do an example. So take a look at example 1 in the text, and this is on page 647. So what we've got is this. You have a $620 bill that was due on March 10th. Now, a purchase is made on the 15th. And that was for $214. And then $67 30th. Now a payment I'm going to mix up the times here a little bit. March 22nd. So if the interest on the average daily balance, so we're going to calculate this average daily balance. In fact, let's do that now. And we'll finish the rest of the problem in just a bit. So let's take a look at this. Now, the billing cycle ends on April 10th, but starting March 10th, we owe $620. Then on the 15th, we make another purchase. Then on the 22nd, we actually make a payment of $200. And on the 30th, well, we get another charge for $67. Now, this is going to be a 30-day billing cycle that ends on April 12th. So what we want to do to compute the average daily balance. Let's see here. So starting at March 10, let me put it this way. So March 10 to March 14, we owe $620. Now this is going to be 5 days. Now from March 15, let's see here, to the 21st, and I think there's an error in the text. I think they mean, if you're following along on page 647 where it has date, it says March 10 to 11. I think that should be 10 to 14. I think there's a little typo there. No, what we did on March 15 is we bought something else. So we have our 620 plus $214. Now we're up to $834. So on the 15th, we made this purchase. And so we're going to have $834 that we owe from the 15th to the 21st, but it's going to change. And the reason is this. On the 22nd, we made a payment of $200. And that's going to pretty much keep our balance at 834 minus 200. Now we owe 634, starting on the 22nd. And then there aren't any more changes all the way through the 29th. But then on the 30th, this will go till April 9. Just more change. We bought something for $67. 634 plus 67. And that's 701. Now let me take a look at, so this is what we've done so far. I'll give you a second to write this down. But what we're looking at, pardon me, I'm just going to check the map real quick, see if anything's changed. All right, sorry, I'm going to do myself a favor, do you a favor, and minimize the election map. Anyway, so for 5 days, starting on the 10th, we have this $620 debt. And that goes for 5 days until we get to the 15th and we buy something else. So this, we have 15, 16, 17, 15, 16, 17, 18, 19, 20, 21. Counting days is always a tricky thing for me. I'm not sure why that is. Because we all have our certain math things that kind of like, nah. Anyway. So for 22 to 29, what we're going to get here should be 8 days. That's what it's going to be. And then for the 30th to April 9, it's 11 days. Not sure why that is, counting days and years anyway, for another time. So we have 5 days with this balance until we buy something else, and then we have 7 days with this balance. Then we have 8 days with this balance, and 11 days with this balance. Now what we could do is we could, just for every single day, list the balance. And that's what we did in the example before. So for example, this right here. So the first day, we owe 620. Second day, 620. Third day, 620. Fourth day, 620. Fifth day, 620. And day 1, day 2, day 3, day 4, day 5. And then for day 6, 834, day 7, 834, day 8, 834, on and on until we have 7 days with 834. There's an easier way of doing this. And we'll have 30 entries is what we'll have. 5 entries of 620, 7 entries of 834, 8 entries of 634, 11 entries of 701. We add up all those entries to get the sum that goes into the top of that fraction. There's an easier way. The easier way is this. Instead of going 620 plus 620 plus and so forth, we'll just write 5 times 620. That's going to make life easier. So this 5 times 620. This 7 times, what was that number again? 834. This will be 8 times 634. This will be 11 times 701. So there we go. So what we're going to do, and then since this is okay, so we're good. So what we've got, let me see here, let me check one thing. Now this billing cycle, I'm sorry, I made one mistake. It's a 31-day billing cycle. So we're going for 31-day billing cycle. And the way you can check, the number of entries should equal the number of days in your billing cycle. Any questions about that? All right. So what we're going to have is this. Squeeze this in there. 11 times 701. And we have 31 days in this billing cycle. And again, if you're going from March 10 to April 10. So that being the case, that's going to give us 31 days. So the way you can check again, 5 plus 7 plus 8 plus 11 is going to give you 31. So if we do this calculation, what we're going to get $21,721. Whew. It's again 31 days, not 30. And divide by 31. And we're going to get, we'll round it to the nearest cent, $768. That's your average daily balance. So we've calculated this. Now let's look at the rest of the problem. What do they want us to do? And what we're going to get is this. The interest on the average daily balance. Now, the interest, we're going to use this interest to calculate the penalty. And for this problem, it's 1.5%. So what we're going to do, we're going to calculate the interest. And what we're going to do is calculate interest, but not on the amount that we owe. We're going to calculate the interest on the average daily balance. This will play the role of P in our interest formula. So R is 0.015. P will be the average daily balance, and that's going to be 768. And then time for this, we're going to let time be 1. And they don't really give an explanation as to why they do that. They really don't. but it is consistent with the examples that they use. So just let time be 1. Yeah, I want to be careful rationalizing that for any reason. So we're just going to stick with that and just let time be 1. So we're going to stick with this time being 1. So the penalty or what we're calling here the finance charge. This is going to be the interest we calculate on the average daily balance. So what we're doing is we have another use for this simple interest formula. It's like with the compound interest last time. I mean, we can calculate compound interest using the compound interest formula, but we could also use the compound interest formula to calculate inflation. So here's another use of the simple interest formula, where we can use it to calculate interest, but now we're going to use it to come up with this finance charge. And so when we use it on the finance charge, we use the average daily balance as our P. And again, we're letting T be 1. So if we calculate this through, and I'll just give you the number that they have here in the text, it's approximately $10.51. So that's going to be your late fee at the end of the month. Any questions about that?
Yeah, quite a lot, honestly.
Oh gosh, please ask, please ask.
So is this similar to the chapters 11.2 and 11.3, I'm guessing, because of that symbol I equals PRT?
They are. We're using the simple interest. This comes from section 11.1, and it's just a different, if you want to look back at it. And what we did is we would calculate the interest, usually for an interest rate over the period of a year, or an annual, it's what we call an annual interest rate. Now you could be, paying interest for multiple years, and that's why T would not always be 1. But if you, that's something we would do. It's sort of like when we worked with inflation, we wouldn't have T equal to 1 with inflation, but we had N equal to 1 for inflation. So in this case, T is going to be equal to 1. So
all right. So what the part that confuses the most is how did you get the 0.015 and the 1? Did you get it from that word problem, or?
It's from the problem. So what I did is I calculated the average daily balance just to do it. So I did the first half of the problem. And then the second half is, okay, so the interest on the average daily balance, and this is example 1 on page 647, the interest is 1.5% per month. Find the finance charge on the April 10 bill. So in that case, what you've got is the rest of the problem is what it is. And so they had us calculate the average daily balance, which takes a bit to do. And then you use that to come up with that finance charge. And for this particular problem, the interest rate's 1.5% on the average daily balance when you're computing the finance charge. Now, of course, that could be a different percent for different problems. The one thing I'm not clear on is they're letting T equal 1. And I'm looking for any justification for that I could give you, and I'm not seeing it. So it might be something I might just need to get back to you on. I have an idea of what it means, but I want to check it and make sure I don't tell you something that's not true. But in the 2 examples that they have here, they're letting T equal 1. And let me just double check something before I tell you something that might not be true. Does that help?
Yes, thank you.
All right, good. All right. So let's take a look at something else called annual percentage rate, or APR. So we're going to get kind of a hodgepodge of things here. At least formula-wise, we are. So annual percentage rate, or what you might have heard of as APR. And what they're asking for in this is what they call the effective interest rate. And the idea is going to be this. You're calculating the APR is the interest rate that the interest that's owed on an unpaid balance. The reason they do this, we'll go through an example here that explains why this is important. But there was a bill passed in 1969, it's the Truth in Lending Act. It talks about it on page 649. But the idea of the Truth in Lending Act is this, is the interest rate that's only calculated on the amount owed. And the key thing, it's based on a particular time, not on the original amount that was owed. So the idea is that, and we'll do an example, I'll show you what we mean, is that essentially this allows consumers to compare different loans more clearly. And let me show you what I mean by that. So let's do an example. Now we want to estimate the APR. We're going to use a formula. So let's say let n be the number of payments. Now this is going to be kind of it's not a very transparent formula. It's sort of how they come up with it. I'll have to dig around to find how they did this. But if we let n be the number of payments for this loan across the life of the loan, R is a simple interest rate. The APR is going to be approximately 2 times n times r, n plus 1. So that's a sort of I guess you could say I don't want to call it a math trick, but it's an approximation to what the APR is. Now let me show you why this is important. So R is going to be the simple interest, so like an annual simple interest. Let's say And notice this has no basis on, and this is the key observation, there is no use of the principal. You don't see a P in there. It's just the number of payments across the age of the loan and then the interest rate. That's it. Don't use the principal. So let's say we have this. Let's say a loan requires 6 payments to pay back. Let's say, let's see here, at 10% interest. So we're talking about the actual percentage rate, or what they call also the actual percentage yield. So we've got a percentage of 10%. Now what's happening with this is that when you make these payments, some of your payment goes to how much you owe, and then some of it goes to the interest. There's sort of a balance there, how we're dividing things up. So when we look at the APR in this case will be 2 NR over N plus 1, or 2 times 6 times 0.10. Again, R is going to be always as a decimal. And then 6 plus 1. So that means about 0.1714, or about 17%. So the actual percentage rate, or the actual percentage yield, is going to be 17% compared to, say, 10%, which is what would be the simple interest rate. So the idea with that is that basically, let me see here. Not wish they said more about this, but they don't really seem to. I'll probably come back to this one. I want to do a little more with this. As far as actually calculating it, it's just using this formula that doesn't have a principal. So I'm going to leave it at that. As far as the formula goes, the problems, you're going to have that, but I want to come back to this. I want to talk about this a little more, because you see this all the time. Like just about every advertisement you see for someone selling a truck or something in the dealership, we're talking APRs. But let's come back to that one. That one's always been kind of problematic. So I'll do a little more research on it, look at some other sources. Anyway, now let's take a look at a formula. It's going to get kind of hectic. I mentioned at the beginning of this chapter that you want to do your calculation step by step by step. And this is one of those formulas where you want to definitely do that. So well, let's say we have this. And unfortunately, they use a letter here that we've used for other purposes. So calculating a payment. So the formula for calculating the payment, first off, in the past, we called this the maturity amount. Now we're going to call it the loan amount. So this is like the principal. So regrettably, we're starting to see a different use of letters here. But say that's the loan amount. R is an annual interest rate. And N is the number of payments. So again, we're using a different letter. This would be in the past for compound interest, the number of times we compounded interest. Here it's going to be number of payments. And then T, now this one's going to be the same. Number of years. And finally this. This is going to be our payment per payment period. So what we're going to do, we're going to take a loan for a certain amount. It's going to be some annual interest rate. We're making so many payments per year for this many number of years. And we want to find out what the payment per payment period is. If it's a monthly, if we're doing monthly payments, this would be 10. I'm sorry, not 10. Ooh, 12. 12. And then this right here would be the amount we pay each month. So how does this all come together? Hold on, this is going to be quite a ride. Two sets of parentheses. There you go. So what you want to do with this, especially when you're working on your homework, especially during the test, you want to do what I say is divide and conquer. When we're doing this kind of calculation, calculate R divided by N. So you've got a number here and a number here. Then calculate negative N times T. And then we follow our PEMDAS. We do an order of operations. So let's do an example. So let's say we have this. So let's say we have a refrigerator for $5,995. Who's buying a refrigerator for $6,000? No offense if you own one for $6,000. I mean, I'd probably have like a cooler with ice in it or something. Now, is it true they have refrigerators that will they're smart refrigerators? Like, what? Does anyone have one?
I heard that there are smart ones that are like for Samsung and stuff, but that's all I know.
Like, what do they do?
I guess, I don't know, either change the temperature or open it itself. It goes on and on. I'm not really a Samsung fan.
Wow. All right. Maybe odds are I'll probably encounter one, think it's the most amazing thing in the world, and wish I could buy one. And that's about all I can say. But all right. So anyway, we have this regrettably, sorry, Joseph, Samsung refrigerator for about $6,000. Well, they say it's for integrated technologies. Fair enough. So what we've got is an annual interest rate of, let's see here, 9.5% for 4 years. Now we're making monthly payments. Now we want to know how much is each payment. So we want to translate this so it goes into our formula. So first off, how much are we going to owe? Well, we're taking a loan out for the $5,995. So that's going to be our A. Now our R, now let's put it as a decimal instead of a percent. Now our N is how many payments we're going to make in a year. It's yearly payments in this case. And so N is going to be 12. Let me check something real quick. Just want to double check. Okay, something on the APR formula just kind of hit me. They use in there also, they don't say it's per year. It just says number of payments. So again, we're going to come back to this APR. They don't say that it's based on that. It looks like it's just for the, looks like for the entire life of the loan is what it is. Anyway, sorry to digress. Anyway, so we have A, we have R, we have N, and T is going to be 4 years. Make sure I got that down correctly. Okay. So what I recommend first, let's calculate R over N. It's going to be 0.095 over 4. So again, I'm going to use as many digits as I can. Now for negative NT, it's going to be 12 times 4, negative 48. So now I'm going to plug in the numbers. So we'll have 5,995 and then 0.02375. 1 minus 1 plus 0.02375 to the negative 48. So now we want to divide and conquer. We're going to be really careful with our order of operations. So we want to work at the innermost parentheses first. So that's going to be the 1 plus the 0.02375. I don't want to forget that that number, that 1 plus, is to the negative 48 power. We don't want to forget that. So let's calculate that. 1.02375 to the negative 48. Now on my calculator, what that's going to be, and I'm going to press the X box button on mine. I think with the TI calculators, I'm not sure if you do this for your TI, is it XY? Is that what it is for the TIs? Oh no, for TI, I'm sorry, I remember what it is. It's the caret. You type in your number and the caret. And then you put in negative 48. You can put it in parentheses. It's actually not a bad idea. So what we get when we do that, like my calculator forces you to use parentheses. So again, using as many digits as I can. Oh, wrong one. So what we're going to get next, and still we're just dividing and conquering, we're just doing all these steps as carefully as we can. So we finally divide this by this. Then we multiply that by 5,995. We'll get approximately, well, for our payment, we'll get to the nearest cent, $210.66. Ooh, let me see, I think I might have made a mistake. Hold on. Oh, shoot, I think I did. I apologize. Hold on. No, I did. I'm sorry. All right, my R over N is wrong. Oof. I apologize, I got my N wrong. So N is 12, which we wrote down, but when I put it in the formula, I didn't put 12, I put 4. Let me do that again. It's pretty painstaking, as you can tell. I'll try to go kind of fast since you've seen the calculation already. Let's see. There it is. So I'll just set it up and then give you the answer. So what this will be is our payment will be R over N. 1 minus 1 plus R over N. To the negative 48. A little more room here. Ooh, sorry about that. I didn't catch that. I accidentally divided by the number of years, not the number of payments per year. So if you go through those same steps we just did, what you're going to get is actually 150.61. So any questions about that, other than making sure when you have N, it's the number of payments per year, not the number of years. But again, it's a painstaking calculation, but you do want to take your time on it. It's easy to make a mistake, as well as you can see, but you can easily make a mistake just in the steps of the calculations. So if you take your time and follow your order of operations, that part of it you'll get right. All right. So a version of this is the payoff formula. And I'm going to give you this formula here. I'll give you an explanation of what these mean and why we're using this. So it's very close to saying it's the formula we just had, except flipped. And basically what you can do is this. You can just solve for A. That means if you divide both sides by the big expression in the parentheses from the payment formula, solve for A, you're going to get this. Now let's talk about what we're looking at. So payment is your regular payment. R is your interest rate. So nothing new here. N is the payments. Let me double check this one. Payments per year. Now U is different. U is going to be the number of remaining payments. And that's going to give us a clue what we're going to use this for. So the idea is this. When you have this loan, let's say you decide you want to pay it off. And you're set on a schedule for paying this loan off. Say like you have a 30-year mortgage, for example, and you're going to have monthly payments. So the total number of payments would be 30 times 12, or 360 payments. And let's say you get 20 years into this mortgage and you say, okay, enough is enough. I want to pay it all off. So this is how you figure this out. If you have 10 years of payments left, so it's the number of payments per year times 10 years, or 120 payments if we're going back to that 30-year mortgage example that I'm talking about. Well, how much would you need to pay the bank? And the reason we're doing this is that we're not just paying back what we owe in terms of the principal. There's also interest that's calculated into this. So to pay back what we owe and the interest that we would be paying, we're going to use this formula. So it's a little different, it's a little more complicated. So let me do an example here. Let's see. Just check the time. All right. So any questions about what we're doing?
Is this section 11.3 or 11.4?
Still 11.3.
Oh, okay. All right.
Still 11.3. It's kind of an eclectic section in some ways, at least in terms of formulas. So let's say we have this. So let's say someone has owed, say it's and this is the example they have in the text here at Jet Ski. So this was bought on a 2-year loan. Now, the monthly payment is going to be $84.67. And the annual interest rate let's see, 8.7%. So let's say she wants to pay it off now. How much would she have to pay? This is an amount so we can get out of this loan. Give me a second to write that down. So let's say you've owned a jet ski for 18 months, and this was bought on a 2-year loan. So it's going to take you 2 years to pay this loan off. Now, the monthly payment is $284.67, and there's an interest rate on this loan of 8.7%. But you decide, I want to pay it off now. I want to get it done. Okay, so to pay it off, again, we're not just paying the principal, we're also paying off interest that was to be included. So how do we do that? We got to use this formula. So stop erasing. We're going to need some of this information. So first off, we know our payment. $284.67. We know our interest rate, and as a decimal, 0.087. Now, this is a monthly payment, they said. Monthly payments. So that means, and we don't have a use for in here. It's going to be, well, we do have a use for it. It's going to be 12. And let's see, we're missing our U. So how do we come up with U? So U, remember, now U is the number of payments remaining. Now, the total number of payments for 2 years. Well, we have a payment each month for each year, and we do this for 2 years. So the total payments will be 2 times 12 for 24. So for the life of this loan, for the full 2 years, if we don't pay it off early, for the full 2 years, we're going to make 24 payments. 1 payment at the end of each month. Now, if we pay off early at the end of 18 months, so we've done 18 months of payments are complete. So the total payments are 24 payments. Now we've done 18 months of payments already, or we've done 18 payments. So how many do we have left over? Well, U then will be our total payments if we went through the entire payment schedule, minus the number of payments that we've made, or U is going to be equal to 6. So now we have all the parts. Let's do the calculation. Check my formula, make sure I didn't miss anything. Now again, let's calculate R over N. Let's make sure we've got the right numbers in the right spot. So in this case, 0.087 over 12. Making sure we get this time. 0.087 divided by 12. And we've got that. So now we plug that in where we see R over N. So we have our payments, and that was 284.67. 1 minus 1 plus. And then U we found out was 6. So this will be to the negative 6. And then R over N again. Again, we're going to be careful. Now, 1.00725 to the negative 6. Oh, I'll forget this. And our payment here, that was 284.67. Oh, I forget we're multiplying that. Again, I'm going to keep as many digits as possible.
Excuse me, sir.
Yes.
Sorry, I just wanted to pause real quick. I kind of got confused. So you just did the 1.00725 by the negative 6 power?
Correct.
All right, so you always do that first, right? Before you minus by the 1?
Yes, and what it
Okay.
is, it's your order of operations. You do the exponent before we do any multiplication or division or any addition or subtraction. Now, we did the addition in here because that's in parentheses. So that's fine. You do what's in parentheses first, no matter what. But then once we turn what was ever in the parentheses into a number, then we got to kind of look at the bigger picture.
Okay. All right.
Exponent, that's what it is.
All right.
But that's why I did that. Again, it's just that PEMDAS, that order of operations. But it's something you want to watch. I'll say this. Very common to want to subtract first. You don't want to do that. Subtract after you've done the exponent. So then I've done the subtraction. Now I do this last division. Just make sure I didn't. Okay. And again, just doing it very stepwise. Finally, we do the multiplication. And to the nearest cent, or to the hundreds place. And that's going to be your answer. So any questions about that? All right. So that's going to be it for this section. Again, I'm going to take a look at that APR. I want to get a little more information on that, what's going on. And I'll let you know, it has to do with being able to compare the interest rates between loans, and APR helps you do that. And so when they give you the APR, that's what they should be giving you, so you can tell which loan has a better interest rate, say. And I just want to dig a little more into that. So, but that's it for tonight. Let me know if you have any questions. I'll post this video. And other than that, have a wonderful evening.
All right. Thanks
Sir?
again. You have a good night.
Good night. Justin?
Sir,